Welcome back, Chappelle. And welcome back to yours lesson on the scientific revolution, right? Had an absolute blast the last couple days teaching you all this stuff. This is one of my favorite things to talk about. Also, love all the compliments on this Prezi. I think I'm going to try and make some more of mine like a little bit like this and stuff like that. But really, really quick, let's go ahead and dive head first in this. Let's not dawdle. Let's not worry about telling everybody this thing or that or the other or whatever. But the thing that we need to focus on is the last section of the scientific revolution we spent on reviewing and understanding the setup of the universe, right? Where is the sun? Where is the earth? Who's going around what and stuff like that. We talked about our four big astronomers in that sense. We talked about Copernicus, Brahe, Kepler, and Galileo. Make sure you know those guys and you know those stories going into your test, right? So now what we're doing is we're going to talk about how science is going to move beyond the ideas of the universe and actually how it's going to affect us kind of just like here on a daily basis, right? And a lot of that hinges on the idea that a new scientific method has been created, right? Because of everything that's been going on and because of the beginning of the scientific revolution, and even before and while Galileo was working on all of his stuff with all these things and his telescopes and the moons of Jupiter and everything else, what was going on as well was this breakthrough in a scientific culture. There is now a culture moving throughout Europe that actually is hinging and focusing on science, and everybody is beginning to base a lot of their new things, their new ideas, things that they are learning on literally observation and experimentation, rather than focusing it as well on like assumption and like church law, right? So the big thing that we need to talk about first is two couple of guys that are going to start kind of going in that direction of questioning everything around them and trying to find out some new results, right? So the very first guy is a man named Francis Bacon, which ironically enough, I don't have a picture of him, which is super, super annoying, right? Francis Bacon, though, is an English scientist, okay? In your mind, I want you to think about a guy that's got like a mustache and like a little triangular beard and stuff like that. He always wore a hat, and he actually worked in the parliament in England, right? Worked in the parliament as a finance minister and stuff like that. But Francis Bacon is going to become really, really big, not because he invented bacon, because he didn't do that, but actually Francis Bacon is going to become very, very important because he's going to begin to pioneer a new conceptual idea about science and how it relates to society, right? He's going to actually dictate the ideas in several of his books, one of them being a book called New Atlantis, right? And in this book called New Atlantis, he talked about how there was going to be like basically a big building that was almost going to be like Hogwarts, right? Like Hogwarts, like where like Harry Potter lives. Except there's not wizards there. There are different types of people there. There's scientists there. And people would bring their problems to them. And the scientists would actually create a system of experimentation, a hypothesis, and coming to a conclusion to solve the problems of the people, right? So what Francis Bacon has basically done is he has actually invented, in a nutshell, the scientific method that we use now, that we actually, like y'all use in your chemistry class, in your bio class, and in your labs, where you're like, okay, I think this will happen. Let's design an experiment to see what happens. Let's observe the results of that experiment, and let's come to a conclusion. Francis Bacon is the one credited with kind of coming up with that system, like systemology and stuff like that. Now, another dude, though, is going to come along. He's going to be very important, and he's going to have one of the worst haircuts you've ever seen in history. But his name is René Descartes, all right? René Descartes is going to take the ideas of the scientific revolution, and he's going to begin to kind of grapple with the idea of human reasoning, right? What do we really know? What do we really know about the moon and the earth and ourselves and all these other things? And he's actually going to try and figure out ways to use human reasoning to diminish doubt, right? So he's a mathematician. He comes up with new geometric values. He actually comes up with a lot of different things when it comes to mathematics. For example, René Descartes actually invented this thing called the Cartesian plane, right? The Cartesian plane is the X and the Y axis that y'all use when you're in math class, because literally one night he was laying on his bed and looking up at his roof, and a fly was buzzing around the roof and going bzzz, bzzz, bzzz. Like y'all seen probably before, it's New Orleans, right? Y'all literally run into mosquitoes, flies, and all kinds of critters around down here. So the thing about it is he saw it and he's like, wait a minute, if I made a series of lines going left and right and up and down, I could plot where that actual fly landed and stuff like that. And he basically invented the mathematical planes, the X, the Y axis, and stuff like that that you use in all of your mathematics classes. But another thing that he's best known for is the biggest thing of his philosophies, right? He did a ton of new types of math and things like that. But then one day, he actually looked inward and he was like, wait a minute, I've come up with these new ideas of mathematics. Galileo is coming up with these new ideas about space and like the universe. And then like Bacon is coming up with scientific theories. And the world is growing and changing. And everyone is learning so much. But then he's like, but how do I even know that any of this is real, right? Like Rene Descartes then began to grapple with the concept of existence, right? He actually tried to figure out, he's like, the human mind and this world that we live in, are they one and the same? Does my mind and consciousness exist in this place, or does it exist someplace else, right? Is it a part of my soul? Is it a part of my reasoning? And he started freaking out, and he was just like, am I real? Am I real? Is this real? Is this real? Is this Flip that Mr. Terry recording right now? Is it real, right? How do I know when I come to a stoplight, when a person turns to the right and then they're gone forever and I never see them again? How do I know that they even exist? Word on the street is y'all talked about this a little bit in Mr. Mathern's class, and something that kind of freaks you out and leads to an existential crisis, right? Because really quickly, how do I know Mr. Mathern's real at this moment, right? Well, Descartes begged that question constantly, and he said to himself one day after emerging from his basement, he said in Latin, cogito ergo sum, which is a very famous quote that you should have tattooed in the side of your face for the rest of your existence from this class, and it's very important. Descartes emerged from his home one day and said, I have to exist because I think, therefore I am, right? He said, if you have rational thought, if you've got thoughts whirling around in your brain and stuff like that, then you must exist someplace, right? You must have existence of some type. But the thing about it is you just can't prove that anybody else or any other thing exists in and of itself. So cogito ergo sum, I think therefore I am, right? Rene Descartes, though, phenomenal intellect. Very, very important. And make sure you get that I think therefore I am thing. Then set your tattoo appointment up as well. Then there's also going to be massive breakthroughs in medicine, right? So medicinal things are going to be massively linked to the scientific revolution as well. So the medicinal aspects of it are actually going to be linked directly to a couple of particular scientists, doctors, and other people as well. Like a guy named William Harvey out of England is going to be really big for realizing that the heart actually works like a pump. It actually pushes all the blood through your body. He figures this out actually using a process known as vivisection, where he would dissect animals while they were still alive so he could see the heart actually pumping and moving, right? But scientists and doctors are going to begin to kind of go along this new line, an idea of dissecting bodies and performing these things known as autopsies, right? Trying to figure out how the human body is constructed, where is everything connected, where do our bones connect to themselves, how do they stay inside of our body, why is our skeleton not leaping up and running around, what's our skeleton look like, things like that. Well, the first guy to come along and do this, before William Harvey does his vivisections, before all these other scientists really get into it, that actually begins to kind of go against church law is a man by the name of Andreas Vesalius, right? So Andreas Vesalius is super, super important, because he's not deliberately going against Catholic law and Christian law. But it was a big thing that we need to understand, that for many, many, many eons, it was against religious law to dissect or actually kind of do anything to a dead body. You had to go through a process, a religious burial and stuff like that. So no one ever really got the chance to open one up and see how everything worked and what it looked like, what muscular structures looked like, what were the internal organs, skeletal structure, the circulatory system, the nervous system. How does all this stuff work? Well, then one day, Andreas Vesalius comes along, and he creates one of the very first medical books on anatomy. And this is Andreas Vesalius right here, and an engraving in one of his books. And as you can see, he's peeling back these veins so he can see how the vascular system works inside of this dead body, and he's performing this autopsy, right? He removes the skin so he can see what the muscular structures look like. And his book is a very, very powerful, very, very big tome known as De Humani Corporis Fabricum, right? So if I literally go okay, that's a warm-up. De Humani Corporis Fabricum. So the big thing about it, though, is this book is literally known on the fabric of human beings, right? And the images inside of it serve as the first medical textbook. It's so, so cool. Look, he's literally got these different elements of people being kind of standing up and stuff like that after all the skin has been removed, so you can see what all the muscular structures look like. I've actually seen one of the original copies of this book in real life in Philadelphia. It's at this place called the Mutter Museum. It's super, super cool. And he actually hung up the bodies and stuff like that so he could see how everything worked. This is one of my favorite ones right here. These two pictures of a skeleton and everything like that. And I'm just throwing this out there really, really quickly. This one in particular, I could never get a tattoo because I'm terrified of needles. But man, if I did, I really think one day I would like one of these guys just to kind of connect to my teaching and stuff like that. But that is Andreas Vesalius, and those are the concepts that he comes up with, the idea of performing autopsies and dissecting bodies and trying to figure out the muscular structure. Now, funny enough, too, his very first books, his very first copies of the book De Humani Corporis Fabricum, were actually bound in human skin. Instead of using cow leather to bind his books, he had so much extra human skin lying around from all these autopsies, he had it tanned and turned into leather, and some of his earliest books were actually made of human skin. How cool is that? Like, so now the big thing, though, as well, is another thing's going to come up that you've learned about in science class: the element and development of the microscope. That's right, that right there is the first microscope ever invented, right? That right there is the very first microscope invented by a guy named Anton von Leeuwenhoek, right? Leeuwenhoek is going to be the guy that creates the very first microscope ever to view cells and microorganisms. Now, particularly microorganisms, right? Now, this guy right here, the one that Leeuwenhoek invented, is actually a very simple construction. You put the glass slide right there in the specimen holder, and you look on the opposite side of this through this little hole right there that's got a small glass lens in it, and you can actually look into the specimen. Anton von Leeuwenhoek realized, though, that the microscope was going to be such a big deal because he got a little bit of pond water and pond scum and put it on there and was looking through it, and he saw all these little critters and all these little things moving around and dancing in front of his eyes. And so he realized that microorganisms, and that maybe there is a world far beyond this planet where there's Jupiter and the moons of Jupiter like Galileo was talking about, and that there are universes and Brahe's supernova exists in space. But he was like, there might be a world outside of this planet, but there's another universe that's so small we can't even see it, right? And he pioneers the concept of the very first microscopes. Now, Robert Hooke is a guy that comes along and makes an even better microscope and perfects it. Now, Anton von Leeuwenhoek and Robert Hooke have always had a big war with each other on who invented it first, right? But the thing about it is Robert Hooke is going to be the guy that, as we know of, actually invented his second. Even if he invented it independently of Anton von Leeuwenhoek, his looks much more like a microscope that you know today, right? Like looking at this guy right here, you look through this guy, there's your little light fixture to catch some light and actually light up the specimen, and you look through these little like cylinders, and that's how you actually see everything. But the cool thing about Robert Hooke, though, Robert Hooke versus Leeuwenhoek, remember those are two different guys. Anton von Leeuwenhoek, a Dutch scientist, Robert Hooke, an English scientist. Robert Hooke, though, had a very specific talent. He was a very good artist, and he would actually draw the things that he saw underneath his lenses. This right here is a flea that he saw, and it's one of his most famous drawings he's ever done. Another one is actually of a bug's eyes, and you can see like the hexagonal pattern and stuff like that of the eyes and stuff. It's very, very cool, right? So the thing about it, though, in general, is as you can see, the microscope is going to be very important. And then you're going to have a guy that comes along and he links all the sciences together, right? This man is probably the most important out of all of them because what he invents and creates proves Galileo's theories mathematically. It demonstrates the concepts of Francis Bacon. It connects Descartesian math to all the other mathematics. And he is the great binder of all the other sciences together. And his name is very, very famous, and a lot of you were lied to about him when you were a kid. And you heard that an apple hit him on the head, and that's how he came up with gravity, right? His name, of course, is Isaac Newton, right? Isaac Newton, Sir Isaac Newton, is a very important figure that we're going to take a couple of minutes to talk about, and we're going to need to add a lot to this little bit of a blurb, right? But Isaac Newton is going to use science and mathematics to explain gravity and his famous laws about force, energy, and he even creates calculus, right? But there's a lot of other stuff he did as well. So Isaac Newton was a very, very famous English scientist, leader of this thing known as the Royal Society at one point. But Isaac Newton comes along, and from a very young age, he showed an aptitude for a lot of different scientific thoughts and theories, right? So he comes along and he starts like actually asking a lot of different questions, trying to figure out like, what are all these different elements? How do all these different elements work? What's going on? And he actually was super religious when he was very young. And when he, in his religious fervor, one of the biggest things he was obsessed with is trying to figure out what day the world was going to end, right? And he was convinced that it was going to happen in 1666, right? When he was actually still alive. And also all of these crazy things started happening leading up to that year. In 1665, there was a massive outbreak of the plague in London, right? And then in 1666, over half of the city of London burned to the ground in a huge fire. Now, in these two events, he moved out to his country estate that he lived in outside of London, where his parents actually owned like a small farm. And on that farm, they had an apple orchard. And one day, apparently, he was looking out of that apple orchard and he saw an apple fall off a tree, is the story of which he tells. And that's how he came up with the concepts of gravity, right? He said that there must be some type of force that is constantly pulling us down in conjunction that has to do with the size of the body of the earth that we're standing on. To explain all of this stuff, he has to write a book that's very, very famous. And write this book down. It's very, very important. It's called the Principia, Principia Mathematica. But Principia is fine, okay? The principles of mathematics. So to explain the force of gravity, how it works, and how it bonds all of the planets together in our solar system, and how it keeps everything stuck to the planet Earth, he had to develop the mathematic known as calculus, right? And this becomes a massive thing. He ends up being the president of the Royal Society later on, and then he even goes further and does many more experiments and expands on many more different things, including this famous thing as well. He wrote a book on optics as well later on, and he actually realized something very, very important. He realized that actually all white light is the creation, or white light is literally the merging of all other colors of light together, right? So we actually split white light into several different spectrum colors. But we'll talk more about that when I see y'all again in class, and we'll talk a little bit more about Newton as well, just to cement him a little bit in the back of your mind. But y'all have a great rest of your weekend. Study hard. Check back on the study guide periodically throughout the weekend that's posted to Google Classroom, because I might be adding and subtracting a couple things. But I'll see y'all soon. Study up. Y'all have a good one.